The present presentation is issued from a book that has just been published, and there is the cover of it. You can find it in any Kindle store in Amazon land on the various Amazon sites. The first idea that is studied in this book is the fact that artificial intelligence is definitely essential for anything that has to do with translation, and yet it is extremely dangerous if there is not an expert translator accompanying the machine. If we want to understand tomorrow's or even today's globalizing world, we have to understand too that all the various peoples in this world, nations or not nations, cultures or not autonomous or recognized cultures, are living with a multifarious situation that has to be taken into account completely. Different languages, different cultures, different genders, different ethnic affiliations, different religions, different national affiliations, different ages, and many other differences have to be taken into account to understand this world. And that is the very starting point of how can we cope with that variety, that diversity, without negating it and making it the engine of this globalizing world. The second concept that comes along is that anything that has to do with language in any field has to consider the accountability of what is being said or what being exposed or being explained in the various texts we are confronted with. Accountability means a tremendous lot. We're going to take the example of a simple machine that we use every day, a printer or whatever, and see where the accountability is positioned if there is a real problem with a machine. The machine has to go, or is a produce of a descending accountability first. The descending accountability starts with, at the very beginning, the designer, the one who invent or design the machines, the software that goes along, the hardware that is the basis of this machine, and the translating machine or the printer has a designer, and the designer is the first one who is accountable for what the machine is going to be. Then you have a second level. That designer is going to sell his invention, his machine, which is only a project, to a company that is going to produce the machine. This company is his client company. We are in a B2B relationship, business to business. And this company will produce the machine. And then that machine is going to be provided to another company or another branch of the same company, which will be the public service company that will make the machine available to the general public. And finally, the general public. That's the descending accountability. Designer, producing company, service company, public. I have my machine, translating machine, printing machine, or whatever, and then there's a problem, and I decide to ask for some kind of repairs, of damages. And then you are confronted to the ascending accountability from the public, the user. We go first to the public service company that has sold the machine to the user. That's the guarantee in a way. This company that is going to guarantee the situation and provide the user with a service that will repair the damage or partly repair the damage, this company is going to go up to the producing company that had provided them with a machine and say the problem that has been seen at the end, at the user's end, is your responsibility because your machine was not conceived properly. There was a mistake with your machine. And this producing company is going to go up one stage and go back to the designer and tell the designer, in the end, with the user, the machine you designed has caused great damage. And that damage can be traced to the design of the machine, which you guaranteed us to be perfect. And obviously it wasn't. When you have that ascending accountability line, you see that you cannot provide the public with any machine, and if we speak of translating machine, it is exactly the same thing, without taking into account the accountability of the whole chain that produced the machine and brought it to the public, to the user. When you do that, you find out, or you can take an example, a very simple example, or simple which is not that simple, the case of the plane Boeing 737 MAX, 2 serious accidents, a few hundred people dead. Who is accountable? Is it the pilot who made a mistake, or is the accountability at a higher level? And at once the ascending line of accountability has been pushed forward and upward, and it came, of course, to the engineers who devised the machine, the plane. Those engineers said, but to their bosses and also to the investigation, we had warned you. This is our report. This is our emails. You had been warned by us that there was a problem here and there, technical problem. You overlooked our remarks. We are not accountable for what happens because of that mistake. Then the CEO of Boeing is trying, of course, to understand where the accountability is. And obviously, there was a mistake in the production of the plane. Hence, Boeing is responsible. But is not enough. Boeing was also responsible for training the pilots. And we are dealing here with pilots, foreign pilots, not American pilots, but pilots whose first language is not English. And we have to answer this simple question: in what language was the training done? It was probably done with an automated virtual pilot unit, in which you learn how to use a plane without flying the plane per se. Yes. This automatic piloting unit, was it proper? Was it properly devised? The pilots who were training themselves on that unit, were they accompanied by someone who was experienced in the piloting of the particular plane we are talking of? Was all the guidance and explanation, was it done in English or in the national language or the first language of the concerned pilots? Was it done in the US or was it done in a foreign country? All those elements are going to bring into the picture linguistic problems. And how were those linguistic problems dealt with? Automatic translation with an artificial intelligence translating machine, or a real translator, or even better, someone who was bilingual enough to both understand perfectly English and speak perfectly the language of the pilot, to be sure the pilot, who is supposed to understand English, but English is not his first language, understands the English properly and transfers it to his own language properly. And that was not done with the Boeing 737 MAX, far from it. So the accountability in that particular case goes up to all the designers and producers of the machine. And it has to do with language. It has to do with translating machine. The first thing I would say about translating machine and their qualification or capability to translate is very simple and fundamental in technical languages that have many compound words. If we start from English, it's quite obvious that compound words are Germanic. They work from right to left. But English is a stress language, and if you move a stress from one element of a compound to another, you change the meaning of the compound. It's very well known with, for instance, a superfluous hair remover. That hair remover doesn't remove particular hairs, but is superfluous per se. If you say a superfluous hair remover, it is a remover of hairs, but not any hairs, superfluous hairs. And the machine is not superfluous at all, or is not declared superfluous. It's the hairs that are declared superfluous. If you get into a technical field, a simple rule of that sort, you cannot see it actually on the paper because stresses are purely vocal. So you have to go into the written language and try it with various stresses, and you choose the one that satisfies your understanding. But is it the proper one? And you confront that machine to a written language with no stresses whatsoever in the written language. How is a machine going to do what we do if we want to read such a compound properly? And there are plenty of compounds that are like that, ambiguous, because of the stressing. The machine per se is intelligent. Is it intelligent enough to do what we do naturally? And yet, when we hear stressed compounds, we understand them naturally. But when we produce them from a written text, we do hesitate to put the stresses properly. There are many examples. For instance, this one, it comes from Amazon kitchen department. Portable stainless steel manual coffee grinder for kitchen and outdoor and travel and office. The problem is manual. If you say, the way I've said, portable stainless steel manual coffee grinder, is a coffee grinder that is manual. So you work the coffee grinder with your own hands. There's a handle, and you turn the handle to grind the coffee. But if you say portable stainless steel manual portable stainless steel manual coffee grinder, it's a coffee that is manual. It's absurd. But does the translating machine know? It is absurd. She is intelligent, the machine, but is it intelligent enough to see that kind of difference in meaning? And it is fundamental. You get onto an industrial system, a plane, or an extremely complicated machine, or a nuclear power station, and you can imagine the damage you can cause if you misinterpret a compound, and in technical language, English particularly, there are many compounds. There is another element that is important to take into account. It is the fact that the translating machine has a database of words, structures, many sentences in a certain number of languages, and that translating machine uses this database, which is supposed to be enormous and which is growing day after day, to deal with the language or the utterance or the sentence it is proposed to translate. So we start from the original language database. We have a word, or it can be several words, but let's take one at the moment. A word taken from that database. That word in that database has meanings, and not necessarily one meaning. The word can have 2, 3, 4, a certain number of meanings. And the first thing the translating machine will have to do is determine what meaning it has to pick. It will pick that meaning with the help it can get from the context of the situation of the text. The context, and we could also speak of the co-text, but let's say the context. If it is medical, then the various meaning of the word are going to be reduced to the medical meanings of the word. All the others are going to be excluded. And if there are several medical meanings of a word, the context has to be finer. Can the machine actually understand and extract from what it is given this particular context? If it doesn't, then it will have a problem with three meanings that are attached to the proper medical context. Which one to choose? And there we are entering another element we'll come back to later. The machine is going to use statistics. That is to say, which meaning, medical meaning of that word, is dominant, that is to say, has the highest frequency in the language in a database the machine has. That's how the machine works. And it gives you an understanding that the machine is going to confront to the target language, the second language into which it has to translate it. That target language has a database too. You find out very obviously that the two databases of the two different languages are of course not identical. Not identical in words, obviously, otherwise we wouldn't have to translate. But the corresponding words are not identical in meanings. And for one word and three meanings in one language, you can have three different words in the other language. And many other elements like that. Those, I will call them as biases. And those biases of the database, or databases in that case, there are two, the biases are implicit. Some of them are explicit, but not necessarily. Most of them are implicit. They are carried by the architecture of the database, and they are carried by the statistical approach of the meanings of the words and of the words themselves that classify the meanings and the words according to the frequency they have in the concerned language. Confronted to that target language database, the machine is supposed to look in that database for the proper context. We were in medical, so it looks for medical, the medical sub-database, provided it is similar to the medical sub-database of the original language. From this context, it is going to move to looking for the meaning, the proper meaning, the meaning it had determined as being the meaning of the word in the original language. It is going to find one word with that meaning. Maybe it might find several words with that meaning, and it will have to choose again. How is it going to choose between two or three words that are absolutely synonymous? And we could give many examples. We know that by heart as soon as we do a little bit of translation. And the machine is not going to use its inner understanding of the texture of the word or the feeling the reader might have in front of this word or that word. Is going to choose the proper word by using statistics. And it is the word that is statistically dominant that is going to be chosen, most probably, for the particular word they are looking for and the particular meaning they are looking for. That gives a word, and then gives a translation. And then you have perfectly aware, one word translation. The proposed translation, as we have seen, has been the result of many choices based on statistical probabilities and not on deeper understanding of the language. An example, a very simple example, if you want, and you can try it yourself if you want. If you give to the machine, translate that sentence, this is a case of the pen versus the tank. Google Translate will translate in French, c'est le cas du crayon contre le réservoir. It didn't understand the phrase, the pen versus the tank, as being an idiom, a set phrase with its own meaning. It doesn't have it in its own database. And for Google Translate, tank, the first meaning of tank, the one that is dominant in all its database and in many other dictionaries I checked, many dictionaries, including French, by the way, but English too, the first meaning given by those dictionaries is tank as a container, and not tank as a military device. That's the type of mistakes that can be catastrophic in many areas. There is a famous misunderstanding between a pilot at something like 12,000 feet over Roissy Charles de Gaulle Airport a long time ago, where the American pilot tries to tears actually, the controller downstairs at the airport. My rudder has a problem. I have to go down. What can I do? His rudder was frozen. At the airport, down on the ground, in the control tower, the controller that got the message answered, we don't have any problem with our rudder, so I don't have to tell you anything. You wait for our next message. And rudder for him was radar, actually, in his mind. He had no problem with radar, yet he was seeing the plane up there properly, but the plane wanted to go down. What could the pilot do? With a frozen rudder, and he has to go around and around at 12,000 feet over the airport, waiting for the tower downstairs to tell him, you can come down, and you follow that route. The American pilot took a risk, a tremendous risk. He decided to go down several thousand feet on his own, with no control, and by eyesight. He didn't have an accident, but you can imagine the tremendous situation you were in such a situation, if two planes had crashed one against the other in such an environment. Two planes falling boom down onto underground, a very urbanized airport area and surrounding. That's the kind of thing that an intelligent machine is supposed to deal with, but can it deal with those kind of situations? The last thing we can say is that the machine is always working on what is called a decision tree. That is to say, you have one element originally, you enter it and you find out that you have a choice between two elements. You choose the one you prefer, or the machine prefers, or the machine considers the proper meaning, and then it goes on, and there you have 2 or 3 or 4 different meanings, and you had to choose again. So that's what they call a decision tree. The machine is using such trees systematically, but it is using those trees on the basis of statistics, frequency of words, and in translation, frequency of connection between one word in one language and one word in the other language if the database between the two languages brings together enough translated text from one language to the other and from the other to one, because it has to be both ways. Do those machines have such databases? It has to be explored. It is possible for English and French and German and Russian and even Chinese, but is it possible for English and Lingala, or English and Pearl, or English and Sioux, or Maya, or some other more, let's say, rare and isolated languages? That is not sure at all. Then, when you are translating, as I've shown just with a word, or the case of a word, you are entering a circle, and that circle is or can be extremely vicious in many ways. You start from a database and you go down to the word, the meaning chosen by the machine, the context chosen by the machine, and then you confront that with the second language, and you go up from this time the target database up to the proper context, then to the proper meaning, then to the word, and then a translation. And but some people have been a little bit more swift on the subject and intelligent, and they found out that those artificial intelligence machines are not all working the same way, and they classify them according to two concepts, what is called interpretability and explainability. Interpretability is the fact that the machine gives you an answer to the request, your request, and it is obviously true. You do not doubt at all, or you might say, well, maybe it's not entirely proper language, but it's not false. You consider that the meaning is correct, and you have two levels where the interpretability is going down, and it's going to go down to a point when the solution proposed is no longer interpretable. You have to have an explanation. It has to be explained. You enter the second field of explainability, and there you have several stages. More and more explanation is necessary. That means to say, the field of translation, when you introduce translating machines, artificial intelligence translating machine, in the picture, before, all the translation was done by a human translator. The human translator today is going to use one of those machines. If it is, as long as the machine, the solution proposed by the machine, remain in the interpretability zone, the translator will have to correct some details, let's say, but more or less accept the translation. But it will reach a point when, in spite of the nice look of the translation on the solution proposed by the machine, you will have to introduce a tremendous more and more explanation to understand the translation and to find out that there are many elements that are correct, and it is only explanation that is going to enable you to find out where the mistakes are. Once again, the pen versus the tank, translated into French, le stylo contre le réservoir. Word for word is perfect. Unluckily, it is completely wrong. And to find out it's wrong and to find out how to correct it, you have to think a little bit and to look for an explanation of the mistake and then an explanation that will bring the proper solution. What is really surprising in this example is that in French we use the same word as in English for the military vehicle, tank and tank. And why on earth didn't Google suggest it? Because it gave one solution, a réservoir, and it didn't suggest another one. So when we get to that, with that machine, you find out that beyond the threshold between interpretability and explainability, you move to more and more explanation, more and more human intervention in the translation, and you end up with a human translator working on what the machine proposes and providing the proper translation that it makes or he, the translator, makes by himself or herself, if you prefer. This is very fundamental because the machine is becoming a tremendous help for all translators. The translators save a tremendous amount of time, but the translators are indispensable in the end to really provide a proper translation. I'm talking, of course, of languages that are not so standardized that there is no human intervention necessary. There are many phrases in the world that are so standardized that it's very easy to translate them. But those are few altogether. Few. And fewer than at least we may think. That means to say I am advocating what we call open translation. Open translation, it is always, the machine is supposed to be programmed so that it always take the context of the request in a diversified way. There are several contexts possible around the request that I provide the machine with. The second one is the machine must always take words as having diversified meanings. Not only one, not the dominant one, all of them. And if possible, not classified in frequency, but open. There they are, all the meanings possible. And the translation that the machine is supposed to propose is supposed to be multiple too. Not one translation which is understood by the user as the translation, but several translations, and the user will have to choose the one that is best, or if they are not all of them correct, to actually produce the proper one. And multiple translations, that means diversify context and diversify meanings. When you look at that circle, which is not exactly entirely a circle, but it is circular in a way, and when you put the translator into that situation, the translator is going to accompany the work of the machine from the beginning to end. And if the machine is working as an open translator, the translator, the user in other words, will have to choose at every single stage what is the proper meaning, what is the proper context, and then move towards the translation. This position of the human intelligence accompanying the artificial intelligence is the proper way of using such machine. I would like to add just a few more remarks, and one is important. As soon as we speak of artificial intelligence and software programming, we have paradigm behind that we never see. Those paradigms are the pieces of programs that work in a machine to satisfy your requests. Those paradigms have what they call in the field backdoors. Backdoors are the weak points of a paradigm that hackers are going to use to enter the paradigm and then do their job, or if you want, do what they have to do or what they want to do. And those backdoors are a risk that has to be identified and corrected constantly. That's why most software of any sort are constantly upgraded, because they correct all those backdoors that they find. That's not the only thing they correct, but the backdoors are one thing that is essential. That's for protection, that's for guaranteeing the security of the software you use. Backdoors are definitely a negative concept in software programming. But in translation, that's completely different. As soon as you get a text that is a little bit creative and just personal way of speaking in everyday life, the words for the speaker have different meanings, and he can use this meaning or that meaning, but he can also use one meaning on the surface and speaks as if he meant that meaning, and at the same time keep in mind and keep behind as innuendo another meaning that is going to be revealed later on by an element he's going to add in the discourse, or by circumstances what is going to happen. If a detective says to someone who is under questioning, you obviously are a murderer, you killed Mr. So-and-so, he is questioning a suspect. So he cannot mean what he said. He says that only to impress the suspect and to make him speak, tell the truth. But the investigator is not the one who decides the man is guilty. The one who decides, in fact it's the ones who decide the man is guilty, is a jury in a court. As long as the jury hasn't decided that the man was guilty, the man is not guilty. So the investigator is saying something that he knows is not true, even if he believes it is true. But the motivation is to pressurize the suspect into speaking. That's what I mean by backdoor. The backdoor is that intention of the investigator and the possible other option he has in mind, and when he says to the suspect, "You have killed Mr. So-and-so," he keeps in mind, if he is a good investigator, he keeps in mind the fact that, after all, he might not have killed Mr. So-and-so, and he might be someone else, but if I accuse him, he might tell me something that will lead me to the real killer. That's a backdoor. And in language, those backdoors are essential. Imagine literature. For instance, how many innuendo, understood meaning, understatement, overstatement, and so on and so on. That's not the real meaning of the text. The real meaning of the text is everything that is not said and everything that is hidden behind the words. So if then you confront a real translator, human translator, with a translating machine, and more human translators are going to use in all possible ways translating machine to save time, to save effort, and to make sure they go faster to the proper solution and concentrate their effort on the real difficult points in the translation. The artificial intelligence translating machine is a tool and nothing but a tool. But once again, it's not a spade that plows the garden, that grows, or that sows first and then grows second by watering and taking care of the plants that are going to grow in that plowed land. The human translator remains then essential for the choice of words' meanings, at times for the choice of words when there are several possibilities as for words with the same meaning, and the criteria for that choice are absolutely open. It can be style, it can be sound, it can be music, it can be tempo, it can be rhythm, it can be anything that resonates in the mind of the translator, the human translator, and that he likes. Then the second, the co-text meaning and style, that is to say, everything around one particular word and how that word is articulated into the text, the co-text, what is in the text around that word. And then the context meaning and the relevance of that context meaning. Then the translator is going to try to capture the author's implicit meaning, and that is something that the machine is not really able to do. Implicit meaning that is carried by style. What is style? And there are not two writers who write the same way. That is carried by the authors and the audience's paradigmatically implicit connections. A word brings up in your mind all kinds of connections with other words, and those are definitely only personal, individual, on the side of the author, on the side of the audience, and that the audience is multiple. What's more, no two people read a book the same way because of those innumerable paradigmatically implicit elements each reader is going to project into the text, consciously or unconsciously. Then you come to a conclusion which is very simple. It is not a conclusion. It is a set of working hypotheses. First one, machines emulate man. They don't do the same thing. They try to get to the same end, to the same result. Second, are those machines, translating machines and other artificial intelligence machines, extensions of the human mind? Do they work the way the human mind, and I don't say human brain, human mind work? We could say human brain too, by the way. It's definitely not sure, but I would even say it's definitely not true. The machine works according to its own paradigm and program, which has nothing to do with the human mind and the human brain. Third hypothesis, we have to have in our global world one or several, one is not the best solution, but 2, 3, or maybe 4 vehicular languages. And between those vehicular languages, a very high level of artificial intelligence for translating one from the others, though no artificial intelligence translator will replace a real human translator. Fourth hypothesis, our book libraries are going to disappear and are going to be replaced. They are already in the process of being replaced by virtual libraries. Universities are selling all the books they have in their stacks. I'm buying some every day, or nearly every day. And those books have been digitalized and are on a server on the library, and any student or personnel can access those books if they have a proper university identity or a proper university pass to access this or that book or all the books in the stacks, as any student and any personnel would have been able to do in the old days in the physical library. I do remember in the 1970s getting into the stacks of the main library of the University of California, Davis, to get a book or to look at the books that were listed on the catalog and that were not available in the main reading rooms but were in the stacks, and I had the references, of course, since everything is classified. So I got books out of the stacks all by myself. That's not what happens in many other libraries, like in France. You have to ask, please, can you get me this book from a librarian. In England, in Bristol, for instance, I worked in the library of the university, and once again, I had all the books available under my fingers if I just made the effort to look for them. The next, and that's the fifth hypothesis, we have to have a global copyrighted open access procedure. And there we are far from that. The world is divided between several copyright systems. The American copyright on one side, and then the copyright that is advocated by the international, the Berne Conference, let's say, the World intellectual property organization, WIPO, which include moral rights in the definition of copyrights, or among other rights that are purely copyright, was the US copyright does not include, hence exclude, moral rights from copyright per se. And moral right is introduced by fair use and the rule that goes along with fair use. And then moral right only exists in courts of justice, not in the law. Whereas, according to the WIPO, a normal copyright law and those recently adopted by Germany, Russia, and China are in agreement with those regulations, and they include moral rights in the list of the various rights that are protected by copyright. And we have another system, which is a French system of authors' rights, clearly defining moral rights as opposed to patrimonial rights, and protecting both differently, where that system is not entirely compatible with the WIPO system, for a simple reason, is that the heirs, or the authors, in let's say anything, in any field of creative writing, if they are confronted with adaptation for film or for theater or for anything other form of show, of production, they can oppose this or that particular adaptation for reasons that are their own understanding of the work at stake, and hence absolutely negate the right of the director to adapt the work and produce something that is more in his own understanding than the original author's understanding. We all know the cases of Stephen King and Spielberg, for instance. When Spielberg adapted a book by Stephen King didn't like that adaptation. Of course, Spielberg was powerful enough, so Stephen King, and we were in America anyway, so Stephen King couldn't oppose the film, but he could have rejected his paternity, as he did later on with another film, and by refusing his paternity, then it would have been granted by a court a good share of money to repair the damage done to his image, because the book was not adapted the way he would have liked it to be adapted. He said so, he explained it, he let the film go, it was a success, The Shining, and then he has, in later years, done his own adaptation, which is slightly different. Then we come to the next point, the seventh conclusion, or the seventh hypothesis: copyright holder and accountability. And there, the field of the accountability of any machines, translating machine or not, in the field of economic and social life has to be set on the table and discussed very, very much. We are far from having solved all the accountability problems of a translating machine. You know, if you have a bad user's guide that tells you to do this and that, or you understand it tells you this or that, has been translated 2 or 3 times from an original language into another language and so on and so on. And by doing what you understand from what you have in front of your eyes, you kill yourself. Who is responsible? You, because you're Nassau? The guide that you might have misinterpreted? And if it has been misinterpreted, it's because it was not clear. The translator or translating machine will produce a guide, and you can go on up in accountability. The machine itself that did a bad job, the designer of that machine, is he responsible for the mistake done at the end and that killed one person? That's the responsibility, accountability that you have with self-driving cars. Self-driving cars will have from time to time to break a rule, though they are not supposed to, just to avoid a situation that might become dangerous. And it might be a lot less risky to break a rule and get out of a situation that might become dangerous than to stay in a situation and suffer the catastrophe that may appear in that situation. Road traffic is dangerous, and at times to evade a danger you have to put yourself at risk by breaking a rule and crossing a solid double yellow line. Finally, let's say, translation and accountability being considered as extremely important, you come to the idea that the owner of the means of production have to also share the value, the added value that this machine brings in. They share the accountability attached to the machine and what it does, but they have also to be considered as beneficiaries of the work and the added value of that work done, performed by the machine. That's about all, and then if you want to have special cases and details, you have to go to the book I've already indicated to you, and there it is again. If you can see it, you can find it anyway under my name in any Kindle store of Amazon. Have a good day.